Okay, I would like to begin by acknowledging all those at Soil Health Institute who participated in the work that I'm going to present today. First, Dr. John Shanahan, with whom you'll meet later during this presentation, is the SHI agronomist who leads the data collection with the interviews with our case studies. Also, the soil scientists who presented yesterday also participate. They, in addition to collecting the information and data that they use for their soil measurements, also go back to the research scientists at these locations and collect farm management data. We should have moved to another slide. I just want to make sure I'm properly screen sharing. If not, please let me know. There are several benefits of soil health management systems. Number one is increased soil carbon and organic matter. We saw discussions of this yesterday. And then improved soil structure, decreased erosion, improved water infiltration. Is related to decreased erosion. The water percolates down. It doesn't roll across the field. And then all this culminates in enhanced soil biological activity. But perhaps the most important benefit isn't related to the soil. It's improved public water quality. When erosion decreases, the water percolates down. It doesn't roll across the field and take the nutrients and soil into the public water supply. So there's a separate question. Is there a business case for the soil health management systems? Specifically, do soil health management systems increase farm profitability? The primary soil health production practice is no-till. When thinking about no-till, it's important to recognize that even in conventional till, farmers do not till after the crop is planted. Generally, this is the case in all field crop production. They till in the fall after the harvest of the previous crop, and in the spring before planting of the spring crop. All post-plant weed management and conventional tillage is with herbicides. This is important because as we attempt to increase the acreage of no-till, we can already think about it as we're already most of the way there. Even conventional farmers have mostly adopted no-till. They are of the opinion that they must continue tilling to get the field and seed bed ready for crop planting and production. Strip till is a variation on no-till. It's no tillage on both sides of a narrow strip. And there are other reduced tillage practices that may meet USDA definitions for no-till. And I say USDA because NRCS has definitions of no-till that meets their programs, but when NASS, National Agricultural Statistics Service, collects data for the census every 5 years, they have a slightly different definition of no-till. Cover crops are another soil health practice. There are several considerations that are related to economics for cover crops. Number one, seed species mix. It could be one seed. Winter or cereal rye, it could be a mixture of seeds. Another consideration is when to plant the cover crop, and then when to terminate the cover crop. How to plant the cover crop, then how to terminate the cover crop. Crop diversity is another soil health practice. This is related to crop rotation that involve the cash crop mix and also cover crops. Cover crops may have value added in that the cover crops, after serving their purpose in soil health, could be cut for forage or grazed for cattle. If the farmer doesn't have any permanent cattle, sometimes farmers buy stockers for weight gain, or if there's somebody nearby, they can lease out the acreage with cover crops for somebody else to graze the cover crops. The business case for soil health management system is determined by cost-benefit analysis. Number one, adopting the soil health management system potentially reduces cost. This would be, if you eliminate tillage, you also eliminate the equipment expense, fuel, and labor. If you adopt the soil health management system, it potentially has increased production costs. For example, if you choose to plant cover crops, you have the cost of the cover crop seed and application expenses. And then finally, there could be impacts on revenue. This could be a benefit or a cost. If the yield increases, it's a benefit. If you have to take a declining yield because of the soil health management system, it would decrease revenue. And I will point out at this time, in all the work that we've done, we haven't experienced a farmer that has taken a decline in yield for adopting a soil health management system. This is always a potential consideration. Then all this comes together with the question, are the benefits of adopting the soil health management system greater than the cost? Adopting a soil health management system entails only marginal changes from conventional production methods. Producers do not have to be involved in a complex overhaul of their agricultural production methods. Therefore, the costs and benefits are determined by partial budget analysis. We use the term partial budget analysis because it involves the part of ceasing an initial practice and adopting an alternative practice. This is a matrix that gives a demonstration of how to interpret cost benefits analysis. The first thing that happens if you're in conventional tillage, when you cease conventional tillage, you reduce those expenses. Secondly, potentially you would have some increased expenses, for example, planting a cover crop, or some other expenses may be necessary as you reduce these expenses. If yields increase, what follows from these changes in production potentially is a yield increase or yield decrease. When you sum these up, reduce expenses, additional revenue, you have the total benefits. Likewise, if you sum up the additional expenses and reduce revenue, you have the total cost. So the change in net farm income is the total benefits minus the total cost. Currently, the Soil Health Institute is conducting 125 farmer interviews. All of these will be completed in August 2020, next month. First one is funded by the USDA National Resource Conservation Service, and we're doing this with the National Association of Conservation Districts. NACD helped us identify the farmers to be included. They helped us schedule the interviews, and they also participated and helped us conduct actual farm interviews to collect the data. Our other ongoing project is with Cargill. Farmer interviews in both of these studies provide data for cost-benefit analysis. Also, the Soil Health Institute is conducting its NATION product to evaluate the effectiveness of over 30 soil health measurements at 124 long-term research sites. Because these are replicated experiments, this provides an opportunity to assess the extent that partial budget analysis for soil health management systems may also be repeatable. Our project scientists are going back to the research scientists at these areas after they collect their data for soil health managements, and they're going and collect the farm management data from the research plots. And then we'll compare the costs and benefits from these alternative field activities and inputs, and this will determine the profitability of soil health management systems. In these research trials, the experimental design controls for factors that are not associated with adopting a soil health management system. Therefore, in the research trials, we'll use partial budget analysis that will involve only the factors involved in a change. This is a demonstration of partial budget analysis. This is the field activities and inputs from one of our sites. This researcher who was conducting this had an experiment where it was no-till compared to tillage with the mower plow in the fall after a previous crop, and then a field cultivator in the spring before planting corn. Notice that these are all crossed out because all the other inputs and field activities were identical. This could just very well be one of our case study farms. This is the same way we collect the information for partial budget analysis with case studies. But notice in this replicated trials, the corn yield was 140 bushels for the conventional tillage and 164 bushels for the no-till. This is the way we present the results. We go through, we do the economic analysis, we use our economic methodology to calculate the cost of the reduced expenses. Omitting the mower plow and the field cultivator has a total expense reduction of $21.15. Correspondingly, there were no additional inputs or costs for the no-till. However, with an increased yield, there are additional costs for post-harvest expenses. National checkoff fee for corn is $0.01 a bushel, and then we put in costs for hauling and drying. With the increased yield, there's additional revenue that's a benefit. And instead of using a temporary price, we use a long-term average price for corn of $4.40. Using this price would be supported by the University of Illinois Extension, their farm doc presentations that do periodic means for cost of field crops, and this is what they would have for long-term average price of corn. So when you add the total benefits and take away the total costs, net change in farm income is $121.87 increase. Farmers practicing the soil health management system make two simultaneous decisions each year. Number one, continue the soil health management system or revert to conventional production practices. And the questions we ask them, what would you be doing if you were doing conventional till? Some of them that have been practicing no-till now and other soil health management systems for 10, 15, 20, some of them even 30 years, it wouldn't be reasonable to ask them, well, what did you do when you were doing conventional tillage? Because the technology of production has changed in all that time. And second, we ask them, if you were doing conventional till, would your yield be greater than, less than, or equal to your soil health management system yield? And we ask the question this way is because everybody's yield has increased. Just the general yield trend in agriculture production has increasing yields. And the cost benefit changes are calculated based on the farm description of the initial practice compared to adopting the alternative practice. And the expenses for the initial practice and alternative practice are determined by 2019 cost of inputs and field activities. This puts everything in constant dollars, even though we may be recording field activities inputs that represent years ago. We put everything into 2019 cost. With our Cargill study, we have 100 farmers in 9 states. This work is ongoing and the results will be completed in the upcoming months. Our work with the NACD and NRCS has completed 25 interviews and partial budget analysis, and we have observed successes for soil health management systems in all geographic areas, on all soil types, dry conditions, wet conditions, flat land, sloping land. And our methodology is designed so that when we have the results from the case studies and nation research trials, that our results from a finite sample of farmers can be extrapolated to demonstrate soil health management system profitability for all U.S. acreage. Our results will be robust and not only individual results for farmers that are in the case study samples. With the Cargill study, we did have some questions not directly related to partial budgets. These are the answers for yes to these questions. Crop resiliency. Is the crop more able to withstand stress by weather? Field access, the soil structure increased, the capability to get into the field for planting and harvesting, land, loan, or crop insurance terms, soil organic matter, water quality, future right to operate, right or license to operate. This is 99%. One farmer for this one responded that he was unsure. Farmers who are engaging in these practices are of the opinion that more regulation is coming and they want to be out in front of it. As we do our work with the NACD project upcoming, these are the type of fact sheets that we'll be releasing. You can be looking for these. Also, the NACD is producing videos that will accompany these fact sheets. We do have some average results over 12 farms from this study. These were 12 farms that had corn and soybeans exclusively. The change in income was $44.73 for corn, $29.73 for soybeans. The average yield increase was 5.3 bushels for corn and 1.7 bushels for soybeans. The range was 0 to 20 for corn and 0 to 6 for soybeans. And 5 of them reported yield changes greater than 0. The others reported no change in yield. This is a more detailed presentation of the table that I just showed you, and I want to focus in on just the cost components of this. The expenses. Expenses for corn were reduced by $68.06. And there were additional expenses of $46.63. The net change per acre, just for expenses, is $21.63. For soybeans, the net change in just expenses was a reduction of $53.68, and expense increase for $41.45 for a net change of $12.23. If you put these acreages, for example, for a farm of 1,000 acres, that's 500 acres of soybeans and 500 acres of corn, and multiply that out, the total farm change is an increase or a decrease in expenses of $10,815 for corn, a total decrease in expenses of $6,115 for soybeans. If you sum that up, you get a net change, a reduction in expenses or increase in farm income of $16,930 per year. This is just for a change, this increase in income is just due to a decrease in expenses. So summarizing the costs and benefits of the soil health management system, the Soil Health Institute partial budget methodology that we're using for this analysis is identical to the commonly applied methodology for enterprise budgets that are developed by agricultural economic extension programs and applied in research trials. This is important because we encourage other people to do this type of work also. If you're already doing work as a soil scientist, crop scientist, and you're putting economic analysis to this, you already have the tools in place to do this type of analysis. Partial budget analysis itemizes field activities and inputs for comparing alternative production expenses, production practices, and production practices that regenerate the soil, reduce expenses, and increase farm profitability. And then finally, agricultural production with a goal to achieve soil health is a component of economic efficiency. From the early results that we have, and we anticipate getting confirmation results as we continue our work, if a farmer is not practicing soil health management systems in production, they can't be fully efficient because the cost of production are greater than they otherwise could be if they were practicing soil health management system.